Hey guys, welcome to Computer Science 227 class. Welcome to this informal environment where I'll be trying to teach you, I'll try to do my best to teach you this class 227. So, as I said in the previous email, you guys will be receiving the lectures most likely in this format. In this way, I'll be pre-recording them. Either just the voice or maybe like that with my face. I actually heard somewhere that if a student doesn't see the face of a person who's explaining something to him, in this case, he actually perceives information a lot worse. So, like, it's a lot worse just, it's a lot better to look at me and hear my voice versus just to hear my voice. That's what I heard. I'm not sure if it's true or not. Anyway, so we'll try to do this. Okay, so the lectures will be posted on this YouTube channel. You're more than welcome actually to look at other lectures from other classes. For example, I'm teaching a 318 class, which can be a lot of fun. I'm also teaching 401 class, which is probably not that much fun. But also, I'm also pretty sure that some of the people actually appreciate me giving information about the career, about the job search, about different things like I've seen in my experience. And that's why I will create a separate series of videos on everything I know about the career. I actually feel that I have a lot of things to say, and I actually feel that some students can feel like lost, and I think they can help them. It can help them. I'll create a separate series of videos also published on this YouTube channel. Again, why YouTube? Because I think that, well, number one, if you don't like, for example, me explaining something, if you don't like to come into class, for instance, if you don't think that I'm explaining that well, you actually don't have to watch these lectures at all. There is no way for me to track that. There is no attendance taken. Okay, so you're more than welcome to read the book or watch some other classes online or like watch some tutorials. You can do that. The only problem though is that you will not know what you'll be tested on. That's the issue. Okay. What else? Yeah, you can also, if you feel that you know some topic pretty well, you can actually, well, first off, you can speed up the video. You can watch it quicker. That's one. Second advantage is that I'll be providing time codes, and you'll be able to jump through those time codes. You'll be able to jump to the section of the video which you like the most. So it makes sense. Okay. What else? Yeah. Also, I feel that you can actually get some information for free. Again, if you feel passionate about computer science, if you have nothing to do anyway, you can actually watch lectures from other classes as well, and they can be valuable to you, in my opinion. It can be a lot of fun. Again, 318 is a lot of fun, in my opinion. I'm also teaching something, I'm also teaching 190, right? So if you feel that maybe you want to revise some information, you can do that as well. And I also think that I'm taking a lot of online classes myself, and whenever we have a Zoom call, Skype calls, I feel that honestly there's always some issues. There are always some issues with, for example, a person wants to ask a question, okay, and then his internet doesn't work. There are some issues with the connection, and it's annoying. It's wasting everybody's time. So it's also like, I don't know, I feel that like if I'm talking to you that way, I actually have an opportunity to edit the entire video. I can create an aesthetically pleasing experience for you. I think that can be available as well. Anyway, so as of now, my decision is we're not doing Zoom, Skype, or anything like that. What else? Other announcements. We're working very hard with Professor Rao to make sure that tutoring will be available for you online. Okay, such that you will have Aaron and Caleb and maybe somebody else working with you. Okay, so we're trying to so Professor Rao is working primarily, but she's trying to make it happen. Okay. If you have any questions about the homework, let's say your code doesn't work. Yeah, first off, let's say you don't understand something from this lecture. Okay, you are more than welcome to post a comment there, such that everybody will see that, and I'll try to reply to that in the comments. You can also, if you have a longer question with some, let's say with the code, right? So you wrote some code from the class, from these slides, and for some reason doesn't work, you're more than welcome to send me an email with that. I'll try to reply to you as soon as I can. I'm also going to have office hours. Okay, so you will receive an email with the link in the calendar. Okay, you'll be able to book an appointment with me. It'll be also online appointment. Everything is online. Nowadays, we'll connect over the phone or something like Zoom, such that I will share the screen with you and you will be able to talk about the code. Also, if you have any questions about the slides, let's say you tried to copy the code in the slides in Eclipse and it didn't work, or I guess if you have any questions about the lectures, you're more than welcome to post a comment below this video. You can also send me an email. If you have a question about the code, you can send me the code, okay? You can, for example, if you have a question about the homework, you can actually send me the code. You can say like, hey, like this, Professor Rubin, this doesn't work. I tried this. Just make sure that you actually put your effort into the work before you send it to me, because I don't want to do the work for you instead of you. Okay. What else? I'm going to have online office hours. What that means is that I'll post a link to the calendar. You'll be able to schedule an appointment with me, and we'll talk over the phone or over Zoom. If we need to discuss the code, we'll share the screen over Zoom, and I will talk to you over that. Most likely that we'll turn off the cameras, because that actually eats up the resources and the internet connection as well. Anyway, cool. So as of now, I honestly think that by the way, all these lectures for this class, they will be a lot shorter. I will try to be as concise, as precise as possible, without digressing, deviating to any other topics. Of course, and again, I will not be talking about the job search. It will be a separate series of videos about that, so that's why I will not be talking about that here. My estimate that it will be maybe 20 minutes long, something like this. Definitely not 75, okay? I also feel that, again, since you will have the advantage of YouTube, you'll be able to switch. You will be able not to watch lectures at all. You'll be able to skip some chapters. You'll be able to speed up the video. I think actually for my classes, it can be even better to do it online, maybe, I guess. I don't know. We'll have to see. Anyway, cool. So today's lecture will be number 17. This lecture will be just a replica. It will be completely repeated from the previous lecture number 16. Okay, it'll be zero difference. That's why if you feel super comfortable with the material you learned back then you don't have to watch it. I still would, because this material is it's very abstract. It's not like 190. It's not like some other stuff. It just unfortunately, in order to give you a simplest example, there is so much code we need to type in, right, which is actually given for the homework. There are so many like abstract knowledge you need to have, so that's why I would highly recommend watching this again one more time. But if you don't want to, you don't have to. Okay, let's do it. So sets and maps. Okay, so in a nutshell, a set is an efficient data structure for storing and processing not duplicate elements. Okay, what does that mean? A set is data structure. It's a collection of objects without any duplicates. Okay, so we know that. A map is like a dictionary that provides a quick lookup to retrieve a value using a key. Okay, so we did that. Okay, so a set. Okay, so in Java there is an interface called set, which extends the collection interface. It does not introduce any new methods or constants, but it stipulates that instance of a set contains no duplicate elements. Okay, so what does that mean? How do we know there are no duplicates? The concrete classes that implement set must ensure that if I have two elements, E1 and E2, then E1 that equals E2 is never true. Okay, so that's how we know that two elements are the same. If that returns as true, that means they're the same. Of course, it's not true. Yeah, so that has to be false for any two elements in the set. Okay, hash set. So as I said before, like when you see data structure like this, like hash set, you can kind of guess. If you know what set is, you know what hash table is, you know what hashing means. Okay, so you can kind of guess what that does, how it works. The hash set class is a concrete class that implements set. You can create an empty hash set Okay, so a concrete class that implements set. Okay, so set was an interface. Now hash set is a class. You can create an empty hash set using NOR constructor. By default, the capacity will be 16 and the load factor is 0.75. If you know the size of your set, you can specify the initial capacity. Okay, otherwise the default will be 16 and the load factor will be can be anything between 0 and 1. Okay, now the question is, what is the load factor? Okay, so let's talk about that one more time. Load factor measures how full the set is allowed to be before its capacity is increased. When the number of elements exceeds the product for the capacity and the load factor, the capacity is automatically doubled. Okay, so for example, if the capacity of the load capacity is 16 and the load factor is 0.75, the capacity will be doubled to 32. Right, so 16 times 2 is 35. When it reaches the size, 12. Why? 16 times 0.75 is 12. Okay. A higher load factor decreases the space costs, but increases the search time. Generally, the default load factor is 0.75, and that's a good trade-off between the time and the space costs. Okay, cool. So, hash table. Let me show you. Let's look up an image from the hash table. Let me pick something from, okay. Yeah, okay, cool. So let's say that is our hash table, okay? So now what I want to try to explain is this. What does it mean when a higher load factor decreases the space cost but increases the search time? Okay, so load factor, what is a load factor? Load factor is a number between 0 and 1 which denotes when you will be doubling the size. Okay, so here's an idea. If let's say that is my hash table, okay, so can I open image, new tab? Okay, now I'll try to zoom in. Okay, cool. So let's say that is our hash table. Okay, so how many entries does it have? 0, 1, 2, so 8, so 9, sorry, right? From 0 to 8, that's 8, and then total is 9. Okay, so if the load factor is 10%, is 0.1, what does that mean? That means when 10% of the hash table is filled, right? When the hash table is 10% full, it means we need to increment the size. We need to double the size by 2, okay? What does that mean? In our case, there are 8 entries, okay? So what is 10%? Is 1 probably, right? So in other words, when we just insert one number, let's say 1, it's being mapped over here. When we just insert one number, the whole hash table is being doubled, okay? And that is actually too early, right? So only one entry is full and you already doubling the whole thing. That's probably too much. That's probably too early. That's why it's not the best idea. At the same time though, if let's say the load factor would be, I don't know, 100%, like 1, okay? That means we're not going to double, we're not going to create any new entries, we're not going to double the size of the hash table until what? Until the size reaches, let's say, like in our case, it's 8 times 1, until the size reaches 1. So until we'll fill out all the entries here, we're not going to double the size, which is obviously bad because because imagine the situation when you have 7 out of 8 elements already filled, and now you inserted one more element, and you have to wait. You basically have to wait a lot of time until it gets mapped to the only one entry which is left. Okay, so that's inefficient as well. That's inefficient. That's why 0.75 is actually like the good trade-off. Trade-off meaning that, okay, so if I increase the load factor, that increases the search time. If I decrease the load factor, okay, so that decreases the search time, right? But at the same time though, it increases the space costs. Hope it makes sense. Oh, link hash set, what is that? So link hash set extends hash set. Okay, so hash set again is a concrete class, hash set, right? So link hash set is basically a hash set, okay, where all the elements are linked to each other. Okay, so again, the idea is this: when you're trying to insert elements in the hash table, they go through the hash function and they map to random entries, right? So there is no way for you to know like how they map there. And then when you print them out, when you print out the hash table, right? So in this particular case, we got lucky, right? So we insert 1, it's been mapped here, 3 mapped here, 5 mapped here, 7 mapped here. Okay, so if you print them out, it'll most likely print out 1, 3, 5, 7, right? But what if I don't know, what if you inserted them in the opposite order? So first off, you inserted 7, okay, it was mapped here, 5, and then 3, which comes here, and then 1, which comes here, right? Then what happens when you print it out, the hash table? It will print out 1, 3, 5, 7. Okay, so that's probably not what you want. Or probably yeah. So it's in other words, there is no way for you to know what order hash table is going to print out the values. Okay, so in order to avoid that, what do? We create so-called linked hash set. What linked hash set does, it first creates a linked list, okay, of these numbers. So 7 will be linked to 5, 5 will be linked to 3, 3 will be linked to 1, and then when you insert them, they're also linked, okay? And in this case, when you're trying to print out a linked hash set, when you print that out, they're guaranteed to be printed out in the order they were inserted. Okay, because they're linked. Again, the elements in the hash set are not ordered, but the elements in the linked hash set are ordered. Tree set. Okay, so sorted tree set. Okay, so what do you know? Again, so judging by the name, you can kind of guess what it does. So tree set, what does that mean? So I have a set. What is a set? Set is collection of elements without any duplicates. Now tree, what is a tree? It's like a binary search tree, for example, right? So that'll be a tree. Sorted set is a sub-interface of set. Okay, so it's an interface which implements interface set, which guarantees sorted set that the elements in the set are sorted. Okay, so additionally provides the methods first, last, for returning the first elements in the tree set, head set, tail set from element into element. Return the portion of the set, the less than to element and greater than to equal to from element respectively. Okay, so what does that mean? We have a sorted set, okay, that implements the interface called set. Okay, and what else does it do? Yeah, and it so the guarantee is that the elements in that set are sorted. So not linked, but sorted. Okay, so if let's say you have a sorted set which is completely empty. Hold on, where is that? Yeah. So if let's say you have a sorted set which is very empty at the very beginning, okay, and then you are what do? You inserted some elements, okay, so let's say you inserted 50, then I don't know, 5, 6, then 7, then 1, then 90, okay. Well, even though you insert them in that order, they will have to be sorted, so they'll be automatically sorted in this data structure, in sorted set. Okay, so they'll become immediately 1, 6, 7, 50, 90. Okay, and if let's say you actually want to insert 90, okay, since it is a set, it doesn't allow any duplicates, so that second 90 will be removed, and that's what you'll get. You'll get only 190 because it is a set. Okay, navigable set, what does that do? Again, it's a sorted set, same thing as this. However, you can actually, it just gives you those four functions: lower, floor, ceiling, and higher. Okay, so you can read in the book what it does. It just, so for example, if you do, if let's say that's what you have, okay, and then you do lower. So let's say lower, I don't know, 7, okay, so lower 7. Okay, so let's think what does it give us? It's gonna give us anything lower than 7. The question is that including 7? less than. Okay, so yeah, so it's not going to include 7, so it's going to return you 1 and 6. Okay, now if you do floor of 7, it's going to return you 1, 6, 7. Now if you do higher than 7, okay, that's going to return you 50 and 90. So basically everything higher than 7. And then if you do ceiling than 7, it's going to return you 7, 50, and 90. So the only difference is what does it include? Does it include 7 or not, right? So lower in floor goes down, higher in ceiling goes up. That's kind of the way to remember that. Or null, right, if there is no such element. So for example, if you say, I don't know, lower 0, right, so then it's going to return you null. Okay, so the pull first, pull last element, remove the first and the last element respectively in tree set. Okay, I hope it makes sense. So that's navigable set. Okay, so tree set. Yeah, so highly recommend doing this all these exercises. That's again during these times when it's very difficult to get a practice. In order not to struggle with the homework, please do these exercises on your own. Just copy this to Eclipse and make sure it works. Perform comparison. Okay, so that'll be your homework, and that's what I'll be talking about a bit later. Maps. Okay, so map is a container object that stores a collection of key-value pairs. It enables the fast retrieval, deletion, updating of the pair through a key. So here, very similar to the hash table as well. So the keys are like indices, list, indexes, integers. In map, the keys can be any objects. A map cannot contain duplicate keys. Okay, each map maps only to one value. A key is the corresponding. Okay, so map is basically very similar to function in maths. Okay, so you have a number and it maps you to some other number. So you provide like imagine a black box. You give a number to the black box and it gives you some other number. So or in other words, it maps to some other number. Okay, same thing for a map. In other words, you have key value. So this key social security number maps to John. This social security number maps to Peter. Okay, so for any one key, you're given only one value. Okay, but for multiple keys, it's possible that you're going to have one value, technically, in the map. Okay, so let's take a look at the functional the structure of a map of classes in the map interface, in the map family. Okay, so we have a map, which is an interface. We have a sorted map. We have a navigable map, which is sub-interfaces. Then we have abstract map, which is an abstract class. Okay, so it's going to contain abstract methods and abstract and constants. Yeah, well, no, abstract class can contain other. No, well, yeah, scratch that. So we have an abstract class called abstract map, and then you have concrete classes. Okay, so the classes which you can actually use, you can instantiate, you can do whatever you want with them. Tree map, hash map, link hash map. Okay, so for the rest of this lecture, okay, I'll quickly go over those methods. Okay, so again, what I like about Java, what I like about programming is that you can intuitively guess what those methods do. Okay, so for example, clear, what does that do? It clears, I don't know, get, what does that do? It returns the value of a specified key in the map, right? So if you learn how to read this, how to read documentation, you can actually easily understand what the method does. Remove, for example, size. What does size do? Size returns the size, of course. Anyway, so let's quickly go over them. Update methods. Okay, include clear, put all, remove. Okay, so clear clears, put changes, put all changes. So it puts map into a map. So map m into the map. Remove. Removes object, removes the key value pair from the map. Okay, what else? Contains key, contains value, is empty size. So size returns you the size, is empty returns you true or false. It returns you true if it's empty, false if it's not empty. Contains key returns you true if this key is there in the map. Contains value returns you true if that value is there, right? What else? You can obtain a set of the keys in the map using the key set, okay, and a collection of the available values method, okay, map entry, so yeah, okay, you can do all of that. Maps get key, get value, set value. So get key returns you the key from this entry. Okay, so for example, get value does, so that's the interface map.entry, okay, returns the value, set value sets the value to v, okay. Abstract map is a class that is a convenience abstract class that implements all methods in the map interface except the entry set method, okay. Hash map, link hash map, tree map, again, you can guess what they do. So tree map is like kind of like a tree set, hash tree, so like tree map will be a map which will be created kind of like a tree, okay. A linked hash map, so you can kind of guess what that does. You have a map which contains a hash table and all the elements are linked. So hash map, again, the same thing. So it's like a map which is done using a hash table. Usually when people in computer science talk about a hash table, what they mean is this. They mean a map, they mean a hash table, right? Which is kind of, they talk about the hash table. We have two columns, key and the value pair. Okay, so usually when people talk about hash tables in computer science, that's what they mean. They mean hash maps in Java. Okay. Yeah, so you can read all of that. Please read all of the descriptions. I just don't want to spend your time actually reading them, like, because that's kind of the book provides the best explanation ever. Okay. For example, the hash map class is efficient for locating the value, inserting an entry and deleting an entry. Hash map, okay, yeah, by the way, hash map is, so hash map is probably the best class you can use. Link hash map extends hash map with a linked list implementation. Again, so linked hash map would be the same thing as a hash map with the elements linked to each other, okay. So the entries in the hash map are not ordered, but the entries in a linked hash map are ordered. Same thing for the set, like, right, so list, linked sort set, link sorted set, same way, right? So known as the insertion order, or the order they were last accessed, okay. Don't know our constructor constructs a link hash map with the insertion order. To construct link hash map with the access order, you need to create this. You need to use this this constructor, initial capacity, load factor, and true. So true, false, right? So if you say true, that means that you'll be doing the X order. That means the elements will be linked not in the order they were inserted into the hash map, but in the order they were accessed after which they were inserted. Okay, so they were inserted first, then you can access them separately, right? So like, again, you inserted some elements in the hash table, then you pull out maybe a few, you access them, and then every time you do that, the linkage, the way they're linked, is changed. Okay, so tree map, again, a map using a tree, class is efficient traversing the keys in the sorted order. The keys that can be sorted using comparable interface or the comparator interface. If you create a tree map using our constructor, comparator method in the comparable interface is used to compare the keys in the map, of course, assuming that the class with the keys implements the comparable interface. To use a comparator, again, if you guys forgot what comparator and comparable is, please look it up in the book. To use a comparator, you have to use tree map with the comparator. Okay, so you provide in this your own comparator, your own way to compare the elements to identify which one is greater, so which one goes first, which one goes last, which one goes next. Constructor to create a sorted map that uses compare method in the comparator to order the entries in the map based on the keys. A sorted map, so can you guess what that does? It's of course it's a map which is sorted. It guarantees that the entries in the map are sorted. Additionally, provides the methods first key, last key. What does it do? It returns the first element, last element in the map. Head map to key, tail map to key. It's a very similar, just different names of like lower and higher. Okay. Returning a portion of the map whose keys are less than to key and greater than or equal to from key. Okay. What else? Okay, sorted map, right? Map. Okay, yeah. Okay, now navigable map extends sorted map. Okay, so navigable map is similar to what? Is similar to navigable set. Navigable set. Yeah, so navigable set, right? And here we have navigable map. Exactly the same thing. Over there we had a set. Okay, so basic collection of objects. Over here we have a map, which is a hash table, key value pairs. Navigable map extends sorted map to provide navigable methods lower key, floor key, ceiling key, higher key. Exactly the same thing as is done here. Lower floor, high ceiling, lower floor, high ceiling. Okay. Poll first entry, poll last entry. Exactly the same thing. Okay. In order to kind of fully embrace that, again, do these exercises, copy that to your Eclipse, and make sure you understand how it works and why it works. There is nothing difficult in it. There is just like maybe a lot of information, and we'll probably do this a bit later. Okay. Again, if you guys have any questions, please comment below. Please send me emails about your questions. I'll try to respond to them as quickly as I could. And that's it for today.